All right, welcome. So today we're going to try to solve another coding problem as usual. Obviously, no guarantees. This stream is for entertainment purposes only. And let me quickly check that everything is working fine. So let's see what's the problem we've got today. So my guess, the hard one. Let's see. And it's the medium one. Oh, is it full self-driving? Check if there is a valid path in a grid. Interesting. Path finding. Nice. Given M and grid, each cell of the grid represents a street. The street of grid I can be 1, which is this left to right, 2, which means bottom to top and vice versa. 3, 4, obviously 5 and 6. All right, so it's you initially start at the street of the upper left cell. A valid path in the grid is the path which starts from the upper left cell and adds at the bottom right cell. The path should only follow the streets. And adds in the bottom left cell. Notice that you're not allowed to change any street. Return true if there is a valid path in the grid, or false otherwise. I mean, to me, it's just simple depth first search problem, right? So the type of the cell tells you which neighbors you might have, either bottom cell or right or left or whatever, right? And we can take one street at there is a it's actually even simpler than that. It's even simpler than that. It's not even depth first search. It's really not. I mean, just look. Every cell has only one neighbor, right? Meaning that from this cell we can only go to another cell. We can go left or right, so there are no choices like at all. So this is simple linear complexity problem, although depth first search is also linear complexity problem, but it's basically just recursion, right? You start until the end, obviously, and you mark every cell where you've been, right? So there's 1, 2, 3, 4, 5, 6. So 0 means we've already visited it. That's it. So we never go back. So once we visited the cell, we go to the type. We know, okay, let's say street 6. So we can go either up or to the left. Then we check, okay, up is already marked 0, means we can go there. We stop, so we continue left. That's simple, right? All right. So, let's see. Do we want depth first search or we want the while cycle? Nah, I would go with depth first search. It's the simple one and it's linear. So I don't think we need to use anything. So let's just quickly code depth first search. Bold DFS. All right. So we say this, and we also say int I, int j, right? So basically coordinates of the current cell where we are right now. So if all right, if I equals, so the bottom cell is what? I equals greed, greed size -1, right? And j equals grid 0 size -1. We know that we have at least one cell there, right? So we should have at least one row. Yes, we have at least one. So we can safely say 0. Then what do we know? Obviously we return true. We somehow ended up at the end of the street. Return true. Else, however, we visit neighbors, right? And if no neighbors, no next unvisited neighbors, no pass, return false. All right, so visit neighbors. So then okay, so we don't need this one. That's my feeling. So we can actually have something like this. So it looks a little bit more clean. So else if greet ij equals 0, right, is visited, return false. It's just for us to not track the previously visited cell, right? Else, so it means we never visited. So we first mark visited. So we saw grid ij equals 0. And then we also have this type, right, which is what? 1 to 6. Type is grid ij, right? And then we say okay, let it mark it as visited. Nice. So that's, we have it. So else if is visited or no cell. So I less than 0 or I greater than grid size, right? Greater or equal grid size, or same thing for J, but 0, or the current cell is 0. Okay, is visited or no cell. Okay, so we don't need to worry about it, right? So then we say switch type. And now I need to remember how the switch works. No, I mean, I think I remember. So, okay, so case. So we know that type is always 1 to 6, right? So we don't need default case, I guess. 1. If it's 1, we return DFS grid. I is, so 1 is what? Is either left or the right, correct? So m times n, so m I believe is grid length, n is number of columns, right? So I fix the I is fixed. I do j minus 1, or, right, because we can go backwards to the visited cell or out of the boundary, or this. So if at least 1 is valid pass, it's okay for us to go this way. Plus 1. Case 2. Then we return DFS. So okay, we fix J now, right? But we subtract it from I, or we say plus 1. No. Like this one. Okay, got it. Case 3. We can go either to the left, which means I is fixed and j is minus 1, or we can go down. And down means, I guess, I plus 1, right? Because I minus 1 is we going up. Might be reverse. So I plus 1 going down. I would imagine how they define top C or left. It depends how you go, whatever. If so, we can fix it later by debugging. Right. Now, if case 4, so we still can go down or to the right. So if we go down, we say I plus 1, and j is fixed, or we can say I is fixed and j plus 1. Nice. And then As you can see, we have only one concern so far is 5 and 6. But we can also have default, which is just, let's say, return false. Never get there due to input conditions, because you also know the type is from 1 to 6. All right, and if it's 0, then we say false. Right. Or actually, we can do this, right? So to simplify here, if no cell default e.g. type equals 0, i.e. already visited. So we don't need loops, so we return false. It's not the valid pass. Otherwise we can keep circling and it never ends. Nice. So in case 5, right, we can go to the left so it's the same as case 3, right? So it's to the right, but then the opposite hand, j is fixed, but we go minus I, right? And here is the same. Going up. So if this doesn't hold, then we can just swap minus and plus signs for I, but we will see. If exactly if we have a neighbor that is part of the pass leading to destination will be true. All right, and I guess we can put this comment from here to here. Nice. Which is a part which is on a path leading to destination will return true. All right, that's it. All we need to say is return DFS grid 0 0. That's where we start. Yeah, we started 0 0. So we started 0 0. I is not less than 0 and j is not less than 0. It's exactly 0, and it's not equal to the end of the grid, right? So this doesn't hold, so we jump here. We take the type, whatever it is. In the first example, let's say it will be 2, which means this, right? So going down. Okay, so let's say first here 2, and here we have 0 0. So 2, we obviously set it to 0, so we never revisit this. We say 2, read I minus 1 j. So we go here, I minus 1, it's 0 obviously, so we can go up. So we say, okay, it's 0, so let's so because less than 0 we return false, so it's false, so it checks this one, and this one is what is I plus 1, right, which is so I becomes 1 and j remains 0, so it's 6, which is this. Right, so we go to the 6 again, I is 1, j 0, so we go back to 0 0. Obviously we find here, so okay, type now is 0, so we say false. Okay, so then when we call the second cell, it will go to the right and check. Oh, actually we were here already, right? That's it. I don't think we need this. We can just say visit neighbors. I've already said this, so I don't think we need this. So it's, let me check, it's else, and then we have a switch type that whatever type we have always returns something. I think we're done. Well, let's see if we pass the initial check, if it compiles. Obviously it won't. It compiles, it reports true. Let's submit and see if we pass all of the checks. Output true. How come? I think I got it. So let's see, 1 is what? Is this, right? So this is like going left, and then we hit the destination and we say we're done, right? The problem is that, all right, let's then not copy it. Let's actually not send the reference, but let's send the copy of it. And then say and all right, let's say this. Okay, bool reverse. So in the reverse, all right, if not reverse, and this return true, then another else if, right, where we check that actually reverse and I equals 0, j equals 0, right, then we return true. All right, so all we need to say here, oh man, we need to say reverse. All right, so this is done, and now we need to say the same DFS. So reverse initially false, so we got it. And we should go also backward. I'm not sure if it's still the fastest way, but it's still linear complexity overall. But maybe you can do this in one pass through, who cares? True, and then we say grid size -1, so it's false, reverse true, and then okay, and grid size -1, okay. Now we're talking. So if this and this, then we have a loaded bus. So it should be bidirectional, right? In our case, it's like directional way works, but we can go reverse. So let's see first of all if it runs still. Yes. And now let's submit and see if it passes now all of the checks. No. Oh man. So what do they want? One, two, and 2, 1. Ah. I see. So those are the tricks that all right, you know what? We don't need the boolean. We don't need to waste our time and our life. All we need to do so let me make it simple again. Let's copy this thing here, right? And then let's have a cycle. Just good old quadratic cycle, right? With int I equals 0, I less than grid size, I plus plus. So basically what we do here in this cycle, we don't need to return it. Okay. We will basically remove all bad cells. What I mean that if the pattern, we hit the pattern and we check all neighboring cells, right? And if those neighboring cells are not bidirectional, I mean the connection from the cell is not bidirectional, if we can get back from that cell to this cell, we return actually, you know what? Wait a second. Look. If we go back, and it's already visited, it's 0, right? So we should return true. I think that's it. Return true, oh sorry, true here. So if it's already visited, we return true. And then we should say and this. But the problem is correct. So this way it will always tell us if there is a pass, right? Because if it leads to the out of boundary, it's bad. All right, so this is even simpler, I think. Run the code. We still have this one reverse, which we don't need anymore. Run the code. And we need to do one more thing actually. I think we need to copy this one. Right? Because we definitely don't want to check so it's not grid ij is 0 0, right? So we mark 0 0 as visited, and then all we need to say here is so type 1. So obviously we know that because j is 0, right? So it will be negative. We don't need to check that. So we say 0 1. Then we don't need to check this one because it will be negative. So we say 1 and 0. We also don't need to check this one. It will be 1 and 0. Alright. So we can just say then this, I guess. So this will be 1. Wait a second. Yeah, I 0, so it can be 1 or j can be 1. Alright. But the problem is, I guess, the valid pass Alright, really in this case it looks like, sorry, so it looks like it's either 0 or vice versa 0, 1, right? So they're either paths going this way or paths going this way, because it starts in a little bit weird space. I'm not sure if case 4 is ever possible to have the cell 0, 0, but let's assume. If it's not valid, then we will say case 4, case 5, let's say case 6 are not valid. So those both are negatives, so this is definitely not valid. So case 5 definitely return false, not valid, right? I guess this one. Is a valid case for start cell. It needs to start. Maybe not. So this is negative. We can go this way. So we go 0, 1, right? So which we can just move here, I guess, because it's 0, 1, right? Either 1 or 6, we go 0, 1. Either 2 or 3, we go 1, 0. This, my feeling, to be honest, should just return false. Right. And default, we can also return false, because obviously there is no such thing as default in this case. Not valid, right? I don't think it's a valid one, but let's keep it just in case. We really have only, basically, in 4 cases we have 2 choices, either go to the left or go down. This is it, right? So once we started, right? So every time we go here, we should say, okay, it's 0, so we already visited it. Let's say the type was 0, right? And we say, oh, type was 0, so we visited it, so it's true. If we hit one of the neighbor is the boundary, that means one thing, it's false. Then true and false is false, so it's false. Run the code, just let's see if it works, and then submit and make sure we pass everything. Right? Submit. This is why. So, but we go to 2. Yes, we go to 2, we return true, right? So so it shouldn't be true. It should be something like this, right? So we take the type. Let me see. So we should hit the previously visited cell, right? So okay, let me go with this one again. Oh man, not that straightforward as I thought it. So the grid is actually is ij, is not like, but whatever. Or we can just say, because we don't need to mark it as visited or something, right? Alright, so all we need to check that the prior cell was already visited, because otherwise if it's boundary, like in this case, it should fail. Alright, so we know that we can't add anything to it, so all addition cases are useless, right? I++, we can go there, can go here, plus can go here, you can go here, right? So it's false. Either this or this. So I would imagine it's also false. False. Because in this case we won't exit the grid, but maybe I'm wrong. We'll see. Then we have DFS. Okay, and this is not valid, right? So we can remove it safely. So I-1, this is case 2 and case 6. Okay. So we don't need this. Right, let's just have it this way. So we don't need a return of this thing, right? Otherwise I would say or, if it's like whatever counts, I don't know. Alright, so what else left? So we have I and I, so we can just say case 3 and case 1. Case 3 and case 1. This or this, or maybe false, or maybe potentially we can enable this. This is what, case 5, right? ij minus 1 and I minus 1j. Okay. Alright. Well, let's see if it's default true. We don't need default. Default also false, I would imagine, for simplicity purposes. Alright, let's submit and see. Output false, expected true. That's what I thought. If we have this weird pattern, we might wish to have for the case 5 only this return, and then case 4 will be with the default, right? Run the code. Alright, submit. Oh man, come on. Alright, so this is what? This is getting ridiculous. So it's, oh man, so basically what we're saying, if grid size, if grid size equals 1 and grid 0 size equals 1, return true. This is special corner case. Whatever. Let's try one more time. Definitely should pass this check now, at least. Man. Oh, come on. Why does it work? I don't know. All right, let's see. So I guess we're already running out of time, but that's okay. This is debugging, so I think we're fine to continue, even though we're over 40 minutes. But the algorithm itself was written, so now we just need to debug corner cases. Who designed this stupid program? All right, so we have this 4 3 3 then 6 5 2, which translates to so first is 4. All right, so 4, then 3, then 5, then 6. All right, so here is a loop, and then we have 3 and 2. So why on earth we return true? Yes, correct, because we hit the loop. This is ridiculous in a way that if it was visited, we say, oh yeah, it was visited, so return true, and that's it, right? And then it's right. So I guess my initial idea that we just want to remove whatever cells we can, right? All bad cells, and then run it in both directions. But we already know that if we run it in both directions, we end up nowhere. So, okay, my feeling is that I know what to do. Yes, it's simple. So all we need to say is actually this, right? So we say greet ij type, then we say type, right? Because it's 0 now. So here we have this bool valid pass. So the pass itself should be valid. Then this valid pass equals this, and then we break valid pass is equal this, and then we break, then valid pass is equal this, and then we break, and finally valid pass is equal false. Right? We don't need to break in this case because obviously it's the end of the switch. So then we return valid pass and you guess it, read, because we know the final cell size -1 0 size -1 equals 0. All right. Should work. Let's see. Run the code. This is now interesting. So when we had just returned this thing, right, when we just returned the DFS directly, man, yes, because we copied. Right. Well, fingers crossed. I guess if this doesn't work, then I give up. Yes! We nailed it with DFS, finally. Not the prettiest algorithm. We have switch case three times because we have special conditions for source and special conditions for destination, unfortunately. But other than that, we nailed it. And I forgot to switch this in, right? So what we did basically, when we had this loop, we decided, okay, let's do the same thing. Let's, for the type, right, mark it as 0. So copy the type and then mark it as visited. So we visited the destination, and then do our corner cases, whatever we have at the destination. And at the source, instead of returning immediately the valid pass, we check two things now. Check the pass is valid, right? And we do it as we did before. And once we check the pass is valid, we check that this is a valid pass, and actually it leads to the destination, because it might be the cycle that somewhere inside, and yes, it's valid, but it doesn't lead to the destination. So let's submit a few more times to see what best scores we can get today. So the time complexity is awful. As you can imagine, but other than that, hey, still wonder, it's like it's linear in the sense of number of cells, right? It just maybe does one extra step, going revisiting prior cell to check if it was visited or not. So alternatively, if let's say you just have a queue-based approach, like breadth first search, right? Because we don't branch, so it doesn't really matter. And we track our prior cell. So we start with 0. And then we have a branch, actually. Then we can go either left or right. And then I guess we go both ways until we had the destination. And then, yeah, it's not clear. Whatever. We solved it with the depth first search. It's just the weird corner cases here. Then we have these two. I would say unlikely. So we have this and this, but so we have 31 and 79. Okay, I'll take it. I'll take it. So whiteboard. So still struggling with getting good performance score on medium problems. 31, round up, and space is way better, 79. So it's 80, 110, right? So, oh, it's above 100, so it's not that bad. Wait a second, what happened? 79, right? And 110. Right, so All right. Bye.